Hello there, and welcome to the Sleep with Science channel. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps the channel to reach more curious minds like yours. Now let's begin. Close your eyes, or let them grow heavy, and let your body sink into the place where you are resting. Tonight, we are leaving Earth behind. We are leaving the Moon behind. We are leaving Mars and Jupiter and Saturn's quiet rings behind. We are traveling past Neptune, past the last world your teachers ever taught you to name, and out into a region so strange, so vast, and so profoundly misunderstood that most people never even learn it exists. Because here is the truth. Pluto is not the edge of our solar system. Pluto is barely the doorway. What lies beyond it is older than the Sun's planets, colder than anything you have ever felt, and far more crowded, and far more restless, than the peaceful black emptiness you might be imagining right now. Beyond Pluto is not empty. Beyond Pluto is not silent. Beyond Pluto is a frontier of ice and shadow, home to hundreds of thousands of frozen worlds, drifting comets with tails that will not ignite for another 10,000 years, and mysteries so large that some astronomers believe an undiscovered planet, larger than Earth, may be hiding out there right now, quietly bending the paths of everything around it. Some call it Planet 9. Some call it a ghost. But whatever it is, its gravity is already writing its signature across the outer dark, even though no telescope on Earth has ever confirmed its face. And that is only the beginning of what waits for us tonight. Because beyond Pluto, distance itself begins to lose meaning. Beyond Pluto, time behaves differently, in the sense that light from the sun takes hours, not minutes, to arrive. Beyond Pluto, the sun itself shrinks to little more than a bright, distant star, offering only a dim gray twilight to any surface that might exist there. It is a place where whispers of the solar system's birth still linger, undisturbed for over 4.5 billion years. Let yourself drift there with me now, slowly, gently, the way starlight drifts across galaxies, patient and unhurried. We begin our journey exactly at the boundary most people believe is the edge of everything, that small, icy, heart-marked world called Pluto. Pluto orbits the Sun at an average distance of roughly 3.7 billion miles, so far that sunlight, traveling at 670 million miles per hour, takes about 5.5 hours just to reach its frozen crust. If you stood on Pluto's surface and looked up, the Sun would appear as nothing more than a brilliant point of light, 1,000 times dimmer than what we feel on Earth, casting a perpetual, dusky blue twilight across fields of frozen nitrogen. Mountains of water ice rise there, hard as granite in temperatures near -387 degrees Fahrenheit. Glaciers of frozen gases flow in slow motion across a heart-shaped plain scientists named Tombaugh Regio, in honor of the young astronomer who discovered this world in 1930. For decades, we believed Pluto marked the outer limit. We believed that past this lonely, wandering dwarf planet, there was little more than starlit vacancy, all the way to the next star system 4 light-years away. But that belief, as comforting as it may have felt, was wrong. Beyond Pluto is not the edge. It is only a threshold, and thresholds, as you may already sense in the quiet of your own mind right now, tend to open onto rooms far larger than the doorway ever suggested. Beyond that heart-shaped world lies the Kuiper Belt, a vast ring of icy debris stretching out to nearly 5 billion miles from the Sun, wide enough to swallow 20 times the distance between the Earth and the Sun itself. And within that ring drift hundreds of thousands of icy bodies, remnants from the earliest moments of our solar system's formation, frozen fossils that have never melted, never changed, never been touched by warmth since before the Earth itself had finished forming. Some of these objects are large enough to be considered dwarf planets in their own right. Eris. Haumea. Make. Worlds you have likely never heard spoken aloud, quietly circling in darkness, untouched by human eyes until only the last few decades. And even this entire ringed structure of ancient ice, this belt that took our fastest spacecraft nearly a decade just to reach, is still, somehow, only the very beginning of what waits further out. Let your breathing slow. Let your shoulders soften into whatever is holding you right now. Because what comes next, beyond even the Kuiper Belt, beyond even the objects astronomers have only just begun to name and number, is a darkness so immense, so cold, and so quietly powerful, that it reshapes everything we thought we understood about where our solar system truly ends, and what might be waiting patiently in the black, unseen, unmeasured, and unseen, until the moment a telescope finally catches its faint, reflected whisper of sunlight. This is where we find ourselves now, drifting past the last-named dwarf planets of the Kuiper Belt, moving into a hush so complete that even the concept of silence begins to feel inadequate. Out here, there is no wind to carry sound, and even if there were, sound itself has nothing to travel through. Space beyond Pluto is not simply quiet. It is a vacuum so close to absolute that scientists still find it difficult to describe in language built for a world with air, and oceans, and birdsong. Let that settle into you for a moment. Let your own breathing become the only sound that matters, slow and even, in and out, as we continue drifting further from everything familiar. The Kuiper Belt, vast as it is, still only accounts for a fraction of what astronomers now believe exists beyond Neptune's orbit. As our instruments have grown sharper, and our patience longer, we have begun to realize that this ring of ice is not a wall, and not a border, but a beginning. Objects within the Kuiper Belt drift so slowly, and lie so far apart, that even though there may be hundreds of thousands of icy bodies scattered across this region, the space between them remains almost incomprehensibly empty. If you were standing on one of these frozen worlds, its nearest neighbor might be tens of millions of miles away, an invisible companion lost somewhere in that thin, star-scattered dark. This is the strange contradiction of the outer solar system. It is crowded, in the sense that it holds far more objects than we ever imagined as children staring up at simple diagrams of 9 tidy planets. And yet it is also lonelier than almost anywhere else we can imagine, each frozen fragment separated from its neighbors by distances that dwarf anything on Earth, distances that make the widest oceans of our home planet feel like a single drop of water. As we drift further still, past the known and catalogued edges of the Kuiper Belt, we begin approaching a region astronomers call the scattered disk. Here, the icy bodies no longer follow neat, calm, circular paths around the Sun. Instead, their orbits stretch and tilt at strange angles, some flung outward by the gravity of Neptune long ago, wandering now on elongated paths that can carry them for hundreds of years before they even complete a single loop around our star. Some of these scattered objects travel so far from the Sun, and then swing back so close, that their journeys alone could outlast every human civilization that has ever existed, repeated again and again in silence, unnoticed and unwitnessed. There is something quietly humbling in that thought. Somewhere out there, right now, a small frozen world is beginning the outward half of an orbit that will not bring it home again for 400 years. It began that journey long before your grandparents were born, and it will not complete it until long after anyone reading, or listening, right now has become part of the Earth once more. Let yourself rest in that vastness. Let it hold you rather than overwhelm you, the way a slow tide holds a boat rather than drowning it. Because from here, deep in the scattered disk, the Sun itself has become almost a stranger. Its light, once so brilliant, so warming, so central to every rhythm of life back home, is now little more than a faint star among stars, indistinguishable to an untrained eye. And yet its gravity still reaches this far, still faintly tugs at every wandering fragment of ice, still holds this entire distant family together in the loosest, gentlest of embraces. It is strange to think that something so distant, so dim, so seemingly powerless at this range, could still be the quiet architect of every orbit out here, still be the reason none of these frozen wanderers simply drift away forever into the true blackness between stars. But even the scattered disk, wide and strange as it is not the true frontier we are searching for tonight. Beyond even these tilted wandering orbits lies a region so distant, so theoretical in parts, that some scientists debate its exact boundaries even now. A place where the objects we do detect seem to behave strangely, as though something unseen is quietly shepherding them, nudging their paths into alignment, whispering gravitational instructions across billions of miles of empty dark. This is where the mystery deepens. This is where the comforting order of our solar system begins to give way to open questions, unexplained clustering, and orbits that should not make sense unless something massive, and massless to our eyes so far, is waiting patiently out there, unseen. We will drift closer to that mystery soon, slowly, the way sleep drifts closer to the mind that has finally allowed itself to rest, unhurried, patient, and certain, the way all great mysteries reveal themselves, not in a sudden flash, but in slow, careful whispers gathered over years of patient watching. Let your body settle a little deeper now, wherever you are resting. There is nowhere you need to be, nothing you need to solve tonight, except perhaps the gentle unraveling of your own thoughts as we continue drifting through this frozen, star-flecked wilderness together. To understand why so many astronomers believe something massive is hiding in the darkness beyond the scattered disk, we first have to understand what they were actually looking for when they noticed something wrong. In the early years of this century, researchers mapping the most distant objects in our solar system began to notice a pattern that should not have existed. A handful of small icy worlds, far beyond Neptune, seemed to have their orbits clustered together in a way that pure chance could not easily explain. Their closest points to the Sun all pointed in roughly the same direction. Their orbital planes tilted at similar angles, as though some unseen hand had reached into the dark and gently arranged them like scattered stones along the edge of a still pond. In a solar system as old and as chaotic as ours, 4.5 billion years of collisions, gravitational nudges, and passing influences, this kind of alignment should have been erased long ago, smoothed out into randomness. And yet it persisted. It still persists today. Let that settle over you the way fog settles over a quiet field at midnight, soft, but impossible to ignore. Astronomers have a name for the leading explanation. They call it Planet 9, though some prefer the quieter, more clinical term, Planet X, echoing an older search from nearly a century ago, when astronomers first went looking for a hidden world whose gravity seemed to be tugging at the edges of Neptune's orbit. That earlier search, in a strange twist of history, is actually what led to the discovery of Pluto itself back in 1930. Pluto, however, turned out to be far too small, far too light, to be the true source of that gravitational influence. And so the question that began over a century ago was never truly answered. It simply went quiet for a while, buried beneath decades of other discoveries, other missions, other more accessible mysteries. But it never fully disappeared. And now, in our own time, with sharper telescopes and colder patience, that question has returned, wearing new evidence and a heavier sense of possibility. If Planet 9 exists, and many respected astronomers believe the evidence increasingly suggests it does, it would be unlike anything else in our solar system. Current models suggest it could be 5 to 10 times more massive than Earth, and yet it would orbit the Sun at a distance so extreme that light itself, traveling at 670 million miles an hour, might take 20 times longer to reach it than it takes to reach Pluto. Some estimates place its orbit at 400 or even 800 times farther from the Sun than Earth itself. At that distance, a single orbit around our Sun would not take 1 year or 100 years, but somewhere between 10,000 and 20,000 years. Think of that for a moment, slowly, the way you might turn a smooth stone over in your palm. A single year on that world would outlast the entire recorded history of human civilization several times over. Empires would rise and empires would fall, entire languages would be born, spoken, and forgotten, and still, this single distant world would not yet have completed one full journey around the star that gave birth to it. And yet, despite years of searching, despite some of the most powerful telescopes ever built turning their gaze toward the region where this hidden planet should be, no one has ever actually seen it. Not once. Not a single confirmed image, not a single point of light that astronomers can say, without doubt, belongs to this world. It remains, in the truest sense, a ghost, known only by the shadow of its influence, the way you might know someone has passed quietly through a dark room only by noticing the door left slightly open behind them. This is one of the strange, quiet truths about the far outer reaches of our solar system. Out here, in the deep cold beyond Pluto, presence and absence begin to blur together. Something can be real, can be actively shaping the paths of dozens of icy worlds across billions of miles, and still remain completely invisible to every instrument we have ever built. There is something almost peaceful in that thought, if you let it settle rather than unsettle you. Not everything that shapes our world, or our solar system, needs to be seen in order to be felt. Some of the most powerful forces surrounding us have always worked in silence, in shadow, patiently pulling at the edges of what we can perceive, waiting, unhurried, for the day we finally develop the eyes sharp enough and patient enough to finally see what has only ever been felt. Let yourself drift a little deeper now, past the edge of thought, into that soft, quiet place where imagination and rest begin to blend together like slow tides meeting along a darkened shore. To search for a world you cannot see, astronomers must become a different kind of detective, one who studies footprints rather than faces, whispers rather than voices. In the case of this hidden planet, the footprints come in the form of those strange, clustered orbits scattered across the outermost edge of our solar system. Objects like Sedna, a small, reddish world discovered in 2003, orbiting so far from the Sun that its entire path takes over 11,000 years to complete. Sedna's orbit is so extreme, so elongated, that at its closest point it still remains farther from the Sun than almost anything else we know, and at its farthest point, it drifts out into a darkness nearly 100 billion miles away, a distance so vast that our fastest spacecraft, traveling at tens of thousands of miles per hour, would still need many centuries just to arrive. When astronomers first plotted Sedna's strange, lonely path, they realized it didn't fit neatly into any of the categories they had built for the solar system. It wasn't part of the Kuiper Belt. It wasn't part of the scattered disk. It seemed to belong to something else entirely, some deeper, colder region that few had seriously considered before. Since then, a small but growing number of similar worlds have been found, each with orbits that echo Sedna's strange isolation, each drifting through the same distant darkness on paths that seem, quietly and persistently, to align with one another. Astronomers gave this pattern a name almost as evocative as the mystery itself. They called it the kernel, a small cluster of extreme trans-Neptunian objects whose orbits seem too similar to be coincidence, yet whose only shared explanation seems to be the gravitational presence of something large, dark, and still hidden nearby. Picture it like this, if it helps you rest into the image. Imagine standing at the edge of a still, dark lake at night, unable to see anything on the water's surface, and yet noticing that every few minutes, small ripples spread outward from roughly the same, unseen point. You never see what causes the ripples. You never glimpse the shape beneath the surface. But the pattern itself becomes its own kind of evidence, steady, repeating, undeniable, even in the absence of a clear view. This is precisely the situation astronomers find themselves in tonight, and have found themselves in for the better part of the last decade. The ripples are there. The clustering is there. Computer simulations, run again and again with different starting conditions, consistently show that the presence of a large, distant planet is the simplest explanation for why these icy, far-flung worlds continue to align the way they do. Without such a planet, the natural chaos of billions of years should have scattered their orbits randomly across the sky. And yet it hasn't. Some deeper order persists, quiet and patient, in the coldest reaches of our solar system, far beyond anything Pluto ever hinted at. But here is where the story grows even stranger, and where your mind, if it is drifting the way I hope it is, might begin to sense the deeper unease at the heart of tonight's journey. Some scientists have proposed that what lies beyond Pluto may not simply be a large, undiscovered planet in the traditional sense. A small number of researchers have seriously entertained the possibility that this hidden mass could be something far stranger, a primordial black hole, no larger than a grapefruit, yet carrying the mass of several Earths, silently distorting the space around it from the shadows at the edge of our solar system. It sounds, at first, like the premise of a late-night thought experiment, the kind that drifts through your mind right before sleep finally takes hold. And yet, it is a hypothesis taken seriously enough that entire research proposals, entire observational campaigns, have been built specifically to test it. Because whatever lies out there, whether it turns out to be an ordinary icy super-Earth, quietly circling in eternal twilight, or something far older, far denser, and far more alien to everything we understand about planets, one truth remains unchanged. Something out there, beyond the comforting, familiar edge of Pluto, is massive enough, and patient enough, to leave its fingerprints across billions of miles of empty dark, waiting quietly for us to finally notice. Consider what patience actually means at these distances. A signal traveling at the speed of light takes over 5 hours just to reach Pluto from the Sun. Beyond that threshold, in the region astronomers call the trans-Neptunian frontier, sunlight itself grows so thin that it could no longer wake a sleeping eye, so faint that noon out there would look, to us, like the deepest hour of night. And yet, even in that starved and silent dark, gravity does not weaken in the way light does. Gravity, patient and indifferent, reaches on and on, bending the paths of smaller worlds without ever announcing its presence directly. This is the strange elegance of the search. No one expects to simply point a telescope and see the thing itself. A body this distant, if it exists, would reflect so little sunlight that it might remain fainter than anything we have ever directly imaged in that part of the sky. Instead, astronomers do something quieter, something almost meditative in its patience. They watch the small ones. They watch the icy, wandering bodies of the Kuiper Belt, and beyond it, the even more distant and mysterious scattered disk, tracking their orbits year after year, decade after decade, waiting for the subtle stutter, the faint gravitational whisper that would betray a hidden mass nearby. It is a little like standing at the edge of a vast, dark lake at night, unable to see the water at all, and yet knowing, by the way distant reeds sway in patterns that don't match the wind, that something large is moving beneath the surface. The first hints of this pattern emerged in the early 2010s, when researchers noticed that a small group of extreme trans-Neptunian objects, worlds with orbits so vast they take many thousands of years to circle the Sun even once, seemed to share something they shouldn't. Their orbits clustered. Their closest approaches to the Sun pointed, roughly, in the same direction. Their orbital planes tilted in eerily similar ways. In a solar system as old as ours, spanning 4.5 billion years of chaotic gravitational shuffling, random objects should not agree with each other like this. Something, the researchers proposed, had to be shepherding them. Something massive enough to impose order at such staggering distance. This is where the phrase Planet 9 entered public imagination, though astronomers themselves are more careful with their language, more comfortable calling it simply the distant perturber, a placeholder for whatever unseen mass is required to explain what the data seems to insist upon. Some models suggest a world perhaps 5 to 10 times the mass of Earth. Others suggest something stranger still. And that strangeness is worth sitting with for a moment, here in the quiet. Because among the more unsettling possibilities considered by serious researchers is not simply a large, cold planet, but something categorically different. A primordial black hole. Not the collapsed remnant of a dying star, but a relic, theorists suggest, of the universe's first fraction of a second, born not from stellar death but from the extreme density fluctuations of the infant cosmos itself. Such an object, if it exists at all, could carry several times the mass of Earth while being smaller than a grapefruit. No light, no warmth, no surface to imagine standing upon. Only a gravitational signature, quietly rearranging the orbits of everything nearby, indifferent to whether anyone ever notices. It is worth pausing here, in this stillness, to acknowledge how strange it is that both possibilities, an unseen icy planet and a relic black hole from the dawn of time, remain, as of now, equally consistent with the same set of orbital clues. The universe does not owe us an easy answer. It rarely has. Consider, too, how differently we would have to think about our solar system if either possibility proved true. We grew up learning of 8 planets, tidy and innumerable, circling a single star in graceful, well-behaved paths. But the outer solar system, the true outer solar system, beyond the reach of sunlight's gentle authority, may be something closer to a slow, cold wilderness, populated not by neat orbits but by long, looping journeys that take longer than the whole of human civilization to complete even once. And somewhere in that wilderness, so the hypothesis goes, one mass, larger than anything else out there, moves along its own impossibly long ellipse, taking perhaps 10,000 years, perhaps 20,000, to complete a single circuit around the Sun. To put that into perspective, the last time such an object would have been at this exact point in its orbit, our ancestors had not yet invented writing. Cities did not yet exist. The idea of astronomy itself was unimaginable. It is a humbling kind of patience, one that dwarfs not just a single human life but the entire arc of recorded history. And it forces a quiet, almost dreamlike question to surface, one worth carrying gently into the next stretch of dark we're about to enter together. If something has been moving out there, unseen, for that long, shaping the edges of our solar system without ever once being noticed by any living thing, then what, precisely, are we searching for when we finally turn our instruments toward it, hoping, at last, to catch a glimpse, or perhaps only a shadow of a glimpse, of something that may have been drifting through that darkness since before the pyramids were dreamed of, let alone built. It is not the kind of search that ends in a single dramatic photograph, the way discoveries so often do in the retelling. It is slower than that, quieter than that. It is a search built almost entirely out of waiting. Astronomers have turned, for this waiting, to some of the widest and deepest surveys of the sky ever attempted. Projects like the Outer Solar System Origin Survey scan the heavens not for one bright object, but for hundreds of faint, slow-moving points of light, each one a fragment of evidence, each one a single thread in a much larger tapestry. And now, with the Vera Rubin Observatory beginning its long survey of the southern sky, astronomers hold a new kind of hope, the hope that comes from sheer scale. Rubin is expected to observe the entire visible southern sky repeatedly, night after night, for a full decade, cataloging tens of billions of celestial objects in the process. If a ninth planet, or whatever we should rightly call it, is out there reflecting even the faintest whisper of sunlight, many researchers believe Rubin may be the instrument finally capable of finding it, not through a single decisive image, but through the quiet accumulation of thousands of tiny observations stitched together like breath slowing into sleep. But light is not the only language astronomers use to listen to the dark. There is another approach, older in concept, almost primitive in its elegance, called stellar occultation. Imagine, if you will, an object so distant and so dim it cannot be photographed directly, and yet, every so often, by pure cosmic coincidence, it passes precisely between Earth and a distant background star. For a fraction of a second, sometimes less, the star's light dims, flickers, and returns, like a curtain drawn briefly across a window and just as quickly pulled away. To notice this requires extraordinary patience, extraordinary luck, and a willingness to monitor millions of stars, night after night, waiting for one imperceptible blink. There is something deeply poetic in this method, if you allow yourself to sit with it. To find something that hides from light, we do not search for its glow. We search, instead, for the tiny wound it leaves behind in someone else's light, a brief absence, a small and fleeting darkness passing across a star that has been shining, uninterrupted, for longer than our species has existed. And then there is the infrared. Where visible light fails, heat sometimes remains. Even an object drifting through the coldest, most sunless regions of the solar system still retains some residual warmth, some faint thermal glow left over from its own formation, or induced gently by whatever starlight manages to reach it at all. Space telescopes designed to detect infrared radiation, first among them the Wide-Field Infrared Survey Explorer, and now its successor missions, have scoured wide bands of sky specifically for this kind of glow, this ember-like trace of heat in a place where heat should scarcely exist at all. So far, these searches have ruled out certain possibilities, certain sizes and certain distances where such a planet simply cannot be hiding. But ruling something out is not the same as finding nothing. It is, instead, a slow narrowing of the dark, a careful tightening of the circle around wherever the truth is actually waiting. There is a strange comfort, and a strange discomfort, in realizing how much of modern astronomy is built this way, not around triumphant, singular discovery, but around this long, unglamorous process of elimination. Each survey that fails to find the object still succeeds, in its own quiet way, at narrowing where it must be, if it exists at all. It is not unlike searching a vast, unlit house for something you cannot see, learning its shape not by touching it directly, but by memorizing every room where it is not. And all the while, the orbits keep whispering their strange agreement. More extreme trans-Neptunian objects have been discovered since that first cluster was noticed, and while a few skeptics argue that observational bias, the simple fact that certain parts of the sky are easier to survey than others, might explain some of the clustering, the majority of the evidence has, if anything, grown more difficult to dismiss with time. Simulations built without any hidden mass at all consistently fail to reproduce the orbits we actually observe. Simulations that include a distant, massive object, tucked far beyond Neptune, reproduce them with unsettling precision. Which brings us, gently, back to the deeper question beneath all of this searching, the one that lingers here in the quiet hours before sleep. Because even if every telescope on Earth eventually agrees, even if the orbits are finally explained and the perturber is finally confirmed, we are still left wondering what, exactly, has been shaping the outer edges of our solar system in complete silence for millions of years, patiently, invisibly, waiting for creatures like us to finally build the instruments capable of noticing that. We were even here to notice at all. Let us drift, for a while, into the physics of what such an object would actually be, if it turns out to be a planet in the conventional sense, an icy, distant world rather than something stranger still. At the proposed distances, somewhere between 400 and 800 times farther from the Sun than Earth itself, sunlight would arrive so diluted that it would deliver less than 1,000th of the light we experience here on a clear afternoon. A world like that would not know day and night in any way we would recognize. It would know only a kind of perpetual dusk, a long, unbroken twilight stretched across centuries, since even its slowest rotation would matter little when the light itself barely changes from one hour to the next. Imagine standing on such a surface, if standing were even the right word for a place with no true horizon in the way we understand it, no warm glow to mark morning from evening. The sun, from that distance, would no longer look like a disk at all. It would look like a single brilliant star, indistinguishable in size from the countless other stars scattered across the sky, except for one detail. It would not twinkle. It would burn with a steady, unblinking light, the only clue that this particular point of brightness held any special relationship to the ice beneath your feet at all. The temperature there would settle into something almost incomprehensible to a species built for warmth. Somewhere near 20 to 30 degrees above absolute zero, cold enough that nitrogen, the very gas that makes up most of Earth's atmosphere, the gas in every breath you have ever taken, would freeze solid, falling not as snow but as something closer to frost accumulating directly onto rock and ice. Methane, in such cold, would no longer behave as a gas at all. It would rest as a solid across the ground, patient and unmoving, a frozen relic of the outer solar system's slow chemistry. And yet, even in that stillness, even in that unthinkable cold, the world would not be inert. Consider Pluto itself, whose surface temperature hovers only slightly warmer than what we are describing, and remember what the New Horizons spacecraft revealed when it finally passed close enough to see clearly, back in 2015. Nitrogen glaciers, slowly flowing across ancient basins, in patterns strikingly similar to the glacial movements we know here on Earth. Mountains built not from rock but from water ice, harder than steel at those temperatures. Evidence, still debated, still studied, that liquid water might exist far beneath the frozen crust, kept warm not by the sun but by the slow, patient decay of radioactive elements deep within the world's own core. If a Planet 9 exists as an icy world rather than something stranger, it may carry secrets like these of its own. A frozen shell above, and somewhere far beneath it, perhaps, a hidden ocean, dark and pressurized, entirely isolated from starlight, entirely isolated from the surface above it, existing in a kind of profound solitude that is difficult for a mind shaped by sunlight and open air to fully imagine. There is something almost tender in that possibility. An ocean that has never known a sky. Water that has never once reflected a star. But sit with the other possibility again, the one that refuses to leave quietly. The primordial black hole. If that is what waits out there instead, then everything we have just imagined, the frost, the twilight, the frozen nitrogen glaciers, dissolves into irrelevance. There would be no surface to imagine standing upon. No twilight sky to look up into. Only a point, smaller than a piece of fruit, so dense that its gravity curves the space around it as powerfully as a planet many times the size of Earth, while its physical presence remains, in every meaningful sense, nothing at all to see. A black hole of that size would not devour ships or swallow light dramatically the way popular imagination often pictures. It would sit quietly, its event horizon barely wider than a bowling ball, its influence extending outward not through visible danger but through the slow, silent choreography of gravity alone. It would occasionally, over spans of thousands or millions of years, encounter drifting comets or icy debris, and in those rare moments, matter falling toward it would heat briefly, releasing faint bursts of X-rays or gamma rays before vanishing beyond the horizon entirely, a small, cold flicker in an otherwise silent void. Some researchers have proposed searching for exactly this signature, these rare and fleeting flares, using space telescopes built to detect high-energy radiation across the sky. It is, again, a search built on patience rather than certainty, on watching an enormous stretch of empty darkness in the hope that, once in a great while, that darkness briefly, quietly betrays itself. And so we are left, still, in this suspended and unresolved place, between two visions of the same unseen object, one a frozen, twilight world with oceans that have never felt starlight, the other a silent point of collapsed spacetime older than the sun itself, and both of them, remarkably, equally capable of explaining the same quiet disturbance rippling through the far edges of everything we once believed we understood. Let us slow down here, and rest for a while on the idea of scale itself, because scale is where the mind so often loses its footing when it comes to the outer solar system. We are used to thinking in distances that fit comfortably inside a single lifetime, a flight across an ocean, a drive across a country, a walk to a familiar door. But the region we are speaking of resists that kind of comfort entirely. Neptune itself orbits at roughly 30 times the distance between Earth and the Sun. Pluto drifts, on average, even farther out, its long, tilted orbit carrying it sometimes closer, sometimes farther, in a slow ellipse that takes 248 years to complete just once. A child born the last time Pluto crossed a particular point in its orbit would have lived, grown old, and been gone for generations before it returned to that same point again. And still, the hypothesized world we are describing tonight would dwarf even that. An orbit 10 or 20 times larger than Pluto's, stretching so far into the dark that sunlight, already faint at Pluto, would thin by another order of magnitude before it ever reached this new, unseen mass. At its most distant point, its aphelion, such a world might drift more than 1 trillion kilometers from the Sun, a number so large that it stops behaving like a number at all and starts behaving more like a kind of silence. It helps, sometimes, to imagine it differently. If the Sun were the size of a single grain of sand resting in the palm of your hand, Earth would be a speck of dust, invisible without effort, drifting a few centimeters away. Pluto, at that same scale, would sit roughly 2 meters from that grain of sand, a small, cold distance you could cross in a few unhurried steps. But our hypothesized world, out at its farthest reach, might rest 20 or 30 meters away, alone, in the dark, far past the edge of the room, far past anything you could see without turning on a light. This is not simply a matter of astronomy. It is a matter of loneliness, in the truest physical sense of the word. At such distances, the gravitational influence of the Sun, the very thing that holds every planet in its familiar, obedient path, grows so weak that an orbit could take not hundreds, but tens of thousands of years to complete. A single circuit around the Sun longer than the entire span of human civilization. Longer than agriculture. Longer than language as we now speak it. It is difficult, even now, to fully absorb what it means for something to be moving so slowly, and so patiently, that its own year outlasts every human year that has ever been counted. And yet motion, however slow, is still motion. Even at these unthinkable distances, this hypothesized mass would still be subject to the same physical laws that govern every falling apple, every orbiting moon, every star wheeling slowly around the center of its galaxy. Gravity does not become gentler with distance out of kindness. It only becomes fainter, stretched thinner across the growing dark, like a whisper carried across an ever-widening room, quieter with every step back, but never fully silent, never fully gone. This is precisely why the search continues to matter, and why so many careful, patient scientists have devoted years, sometimes entire careers, to chasing a single point of light that may or may not exist. Because if it does exist, its discovery would not simply add a 9th or 10th entry to our list of planets. It would rewrite our understanding of how solar systems form in the first place. We have found, in other star systems scattered across the galaxy, an enormous number of so-called super-Earths and mini-Neptunes, worlds larger than our own but smaller than the gas giants, worlds that appear to be among the most common types of planets in the entire universe. And yet, strangely, mysteriously, our own solar system appears to have none. No such world sits between Earth and Neptune. No such world has ever been found closer to our Sun. Some researchers have proposed a haunting possibility that perhaps we do have one after all, just not where we expected to look. Perhaps this common, almost universal category of planet was not absent from our solar system, but simply flung outward, long ago, in the chaotic gravitational storm of the solar system's early youth, banished to the far, twilight edges of everything, and left to orbit there in near total isolation ever since. If true, it would mean the missing piece of a puzzle astronomers have puzzled over across thousands of other star systems has been quietly orbiting our own Sun the entire time, hidden not by secrecy, but by sheer, staggering distance. And so, as impossibly far as this world may be, if it exists at all, it may not be strange to our solar system so much as strangely, quietly familiar to the rest of the universe, a common kind of planet in a place so remote that it simply took us this long to even begin to imagine looking. Consider, for a moment, what it would mean to search for something so large by looking for almost nothing at all. This hypothetical world, if it drifts out there in the dark beyond Pluto, would not announce itself with light, because it makes none of its own. It would not blaze or flicker or call attention to itself in any of the ways human eyes have evolved to notice. It would simply reflect, faintly, weakly, a whisper of sunlight that left our star many hours before, traveled billions of miles through the black, touched the planet's frozen surface, and then began the long journey back, growing fainter with every mile, until what finally reaches a telescope on Earth is not a point of light so much as the ghost of one, a suggestion, a rumor of brightness that most instruments would simply fail to register at all. This is the quiet, humbling arithmetic of searching for a world at these distances. Light dims not in a straight line but by the square of the distance traveled, which means a planet twice as far away is not half as bright, but 4 times dimmer, and a planet 20 times farther than Earth is from the Sun becomes 400 times fainter still. Now push that same planet out to the distances some researchers propose, perhaps 600 astronomical units, perhaps 800, perhaps more, and the light returning to us thins to something almost theoretical, a signal so faint that it hides not because it wishes to, but because physics itself conspires to keep it hidden. And so astronomers have had to become something other than watchers of light. They have had to become watchers of consequence, students of influence, readers of absence. Because even a body that cannot be seen can still be felt. In the same way you might know someone has passed through a dark room not by seeing them, but by noticing that a door which was open is now closed, that a chair has been moved, that the air itself seems disturbed in some way you cannot quite name. Gravity, unlike light, does not fade into invisibility. It reaches. It lingers. It leaves fingerprints on everything nearby, patient and mathematical, whether or not anyone is there to read them. This is why the search for this hidden world has turned, again and again, to the strange clustered orbits of the small icy bodies that already live in that distant region, the Kuiper Belt objects and the more extreme trans-Neptunian bodies whose paths through space seem, to some researchers, suspiciously organized. Instead of scattering randomly in every direction, as pure chance might suggest they should, a subset of these distant, icy wanderers appear to align, their orbits clustering together in orientation and tilt, as though something unseen were quietly conducting them, shepherding their movements over millions of years the way a distant lighthouse might, without ever being seen itself, still shape the paths of ships that pass near enough to feel its pull. It is important to pause here and say plainly that this evidence remains debated, contested, unresolved. Some astronomers see in this clustering a compelling signature of a hidden planet's gravity. Others see something more mundane, an illusion born from the limits of our own observations, the simple fact that we have only found a small, biased sample of these distant objects so far, mostly in the parts of the sky we happen to look, using telescopes that can only see so faint so far. It is possible, these skeptics argue, that the clustering is not evidence of something hidden, but evidence of how little we have truly seen, a trick played not by a planet, but by our own incomplete map of the darkness. And yet, the alignment persists across multiple independent surveys, appearing again and again in data collected by different teams, using different instruments, looking at different patches of sky, in different years. This does not prove the planet is real. But it does mean that whatever is happening out there, whether it is a hidden world or a subtler statistical mirage, it is happening in a way that refuses, so far, to simply vanish under closer scrutiny. Somewhere in this tension between explanation and uncertainty is where real science quietly lives, not in the confident certainty of a discovery already made, but in the patient, unglamorous work of testing a strange signal against every mundane explanation that might account for it, and only when every ordinary answer has been exhausted, allowing the extraordinary one to remain standing. This is not a fast process. It does not move at the speed of headlines or hope. It moves at the speed of light returning from 600 astronomical units away, faint and slow and utterly indifferent to how badly we might wish to already know the answer. And so, for now, the search continues in the way it always has, not through triumphant sightings, but through decades of small, careful accumulations of doubt and evidence, each new data point another faint tug on a thread that may, eventually, lead somewhere real or may simply unravel into nothing, the way so many promising threads in the history of astronomy have unraveled before, quietly, without apology, leaving behind only the humbling reminder that the universe owes us no discoveries simply because we have grown patient enough to wish for them. But if it is real, if this world does exist in the manner some calculations suggest, then its presence would explain far more than a handful of oddly clustered orbits. It would begin to answer a chorus of smaller mysteries that have lingered at the edges of our solar system story for years, each one strange on its own, but strangely coherent if a single unseen mass were woven quietly through all of them. Consider the extreme trans-Neptunian objects themselves, the small, icy wanderers whose orbits carry them so far from the Sun that some spend thousands of years journeying outward before slowly, imperceptibly, beginning the long fall back. A few of these objects follow paths so elongated, so strangely stretched, that conventional explanations struggle to account for how they came to be shaped that way at all. Some astronomers argue that only the steady, patient gravity of something massive, something orbiting far beyond even these bodies, could sculpt such extreme, improbable orbits over the long architecture of time. Not a sudden event. Not a single collision or close encounter, but something slower, quieter, more like the way water shapes stone, not through violence, but through repetition, through the simple accumulated weight of billions of years spent pulling, ever so slightly, in the same patient direction. And then there is the question of inclination, the tilt of these distant orbits relative to the flat, orderly plane in which most of the solar system's planets calmly circle the Sun. It is a strange thing to imagine that space itself, at these distances, might not be flat at all, but subtly warped, subtly bent out of alignment, as though something unseen were tugging certain orbits upward, or downward, away from the plane the rest of the solar system respects so faithfully. It is the kind of detail that sounds almost mythological when spoken aloud, a hidden hand reaching up from the dark to gently tilt the paths of distant wanderers, and yet it is expressed here not as myth, but as mathematics, as the quiet residue of gravitational influence accumulating, unseen, across unimaginable spans of time. If such a planet exists, current models suggest it would not resemble the rocky, familiar geography of Earth, nor would it likely resemble the roaring, storm-wrapped enormity of Jupiter or Saturn. Instead, many researchers who take this hypothesis seriously imagine something closer to a smaller version of Neptune or Uranus, an ice giant in the truest sense, a world built not from solid stone but from a deep, layered architecture of compressed ices, water, ammonia, methane, folded together under pressures we can barely conceptualize, wrapped perhaps in a thin, frigid atmosphere of hydrogen and helium, swirling so slowly, so faintly, that if you stood upon some imagined platform above its clouds, you might wait days, weeks, to perceive any motion at all. Its estimated mass, in the calculations that support its possible existence, ranges somewhere between 5 and 10 times that of Earth, enough to exert real, measurable gravitational influence across the distances involved, but still small enough, still faint enough, still far enough away, to have evaded every telescope and survey that has searched the skies until now. It is a strange kind of scale to hold in the mind, a world potentially larger than our own, yet so distant that its faint light, if any reaches us at all, arrives not as a point we can identify, but as a statistical possibility buried somewhere within thousands of candidate points scattered across deep survey images, indistinguishable, at first glance, from the countless faint smudges of distant galaxies, or the quiet, ordinary noise of the camera itself. This is, perhaps, the strangest part of the search, not that the planet might be hiding, but that if it exists, its light may already have been captured, sitting quietly within some archive of astronomical data collected years ago, waiting not to be found, but to be recognized, waiting for someone to look at the right frame, compare it to the right earlier frame, and notice that one faint point among thousands has moved, however slightly, against the fixed and distant backdrop of the stars. It is a search less like exploration and more like memory, less like discovery and more like recollection, an attempt to notice something that may have been quietly recorded long ago, invisible not because it was truly hidden, but because no one yet knew to look at it in exactly the right way, at exactly the right moment, and understand what they were seeing. And so telescopes across the world continue their long, patient sweep of the outer dark, some searching in visible light, others reaching further into the infrared, where a world this cold, this distant, this internally warm from its own gradual gravitational contraction, might glow faintly with its own dim heat rather than borrowed sunlight, a heat so slight it would scarcely register as warmth by any human measure, and yet still enough, perhaps, to leave the faintest thermal signature. Scattered somewhere among the coldest, quietest corners of the sky, waiting for the right instrument, pointed in the right direction, on the right night, to finally notice what has been there all along. There is something worth sitting with in this idea of a world that might announce itself not through reflected sunlight, but through its own faint internal warmth. Because heat, at these distances, tells a different kind of story than light does. Light speaks of the present, of a surface catching a sun that is already almost a stranger to it. Heat, in the case of a world like this, would speak instead of the past, of energy stored since the earliest days of the solar system's formation, when this hypothetical planet, if it exists, first coalesced out of the same swirling disk of gas and dust that built every other world circling our star. That primordial heat, generated by the sheer gravitational compression of matter falling together, does not vanish quickly. It lingers. It radiates outward slowly, over billions of years, in a long, unhurried exhale that infrared telescopes are built to detect, even when every visible photon has long since become too faint to matter. This is part of why instruments like WISE, the Wide Field Infrared Survey Explorer, and its extended mission NEOWISE, have played such a central role in this search, scanning the sky not for light we would recognize with our own eyes, but for the dim thermal glow that even a cold, sunless world might still emit. And when earlier searches using this method failed to find conclusive evidence of a Neptune-sized or larger planet within certain distances, it did not end the hypothesis so much as reshape it, pushing the boundaries of where such a world could plausibly hide farther out, into regions even survey telescopes still struggle to probe completely, into gaps in the sky's coverage, into the vast, quiet unevenness of how thoroughly humanity has actually mapped the darkness surrounding its own solar system. Because it is easy, standing on Earth, to imagine that we have looked everywhere, that our tools are thorough, that if something were truly out there, surely by now we would have found it. But the sky is far larger than that comforting assumption allows. Even our most ambitious surveys cover the heavens unevenly, dwelling longer in some regions, passing briefly over others, limited by the orbits of our satellites, the rotation of our planet, the specific wavelengths our instruments were built to detect, and the sheer, staggering amount of information that a genuinely complete survey of the entire sky, at sufficient depth and resolution, would require. In truth, large portions of the most distant, faintest sky remain only partially examined, glimpsed rather than studied, sketched rather than mapped in full. This is not a failure of effort. It is simply the nature of the task. Surveying billions of points of light across the entire dome of the sky, distinguishing the small number of genuinely significant signals from the overwhelming static of background stars, distant galaxies, cosmic rays striking detectors, and ordinary instrumental noise, is a problem of scale that even our most powerful computers and most dedicated astronomers can only chip away at, year after year, patiently, incompletely, one survey at a time. And so the search has increasingly turned toward the next generation of instruments built specifically to close this gap, chief among them the Vera C. Rubin Observatory, perched high in the mountains of Chile, designed to do something no previous survey has fully accomplished, to photograph the entire visible southern sky, over and over, every few nights, across a period of 10 years, building not a single snapshot of the heavens, but something closer to a long, continuous film of the sky's slow, subtle changes over time. It is this kind of repeated, systematic observation, rather than any single dramatic image, that offers the most realistic hope of finally catching this hidden world in the act of simply existing, revealing itself not through any deliberate signal, but through the quiet, undeniable fact of movement, a single point of light shifting, ever so slightly, against the fixed and distant furniture of the stars behind it. Because that, in the end, is the only signature a planet this distant and this dim can truly offer us: motion, the unmistakable evidence of something following its own private, ancient orbit around a sun so far away that sunlight itself becomes almost a rumor by the time it arrives. Everything else, the clustering of smaller objects, the strange tilts and stretched paths of icy wanderers, the theoretical calculations of mass and distance, all of it exists only to narrow the search, to tell astronomers where, among the entire dome of the sky, they might reasonably expect to look. But confirmation, if it ever comes, will not come from theory. It will come from a single photograph, compared patiently against another photograph taken years before, revealing that one point of light, among millions of others that stayed perfectly, obediently still, quietly, almost imperceptibly moved. There is a particular kind of patience required to look for something this way, a patience that does not resemble the urgency we usually associate with discovery. It is not the patience of waiting for a door to open, but the patience of watching paint dry across the surface of the entire sky, trusting that somewhere within that impossibly slow, impossibly vast unfolding, a single relevant change is quietly taking place, unhurried, indifferent to whether anyone happens to be watching at the exact right moment. And this, perhaps, is the deeper lesson embedded in the search for this hidden world, a lesson less about astronomy and more about the nature of time itself, at least as it is experienced by anything massive enough, distant enough, to exist almost entirely outside the frame of a single human life. Consider what an orbit actually means at these distances. Here, close to the Sun, on this small, warm, blue world, a year is a familiar unit, a single turn around the Sun completed in roughly 365 days, a rhythm so deeply woven into human experience that we barely think of it as astronomy at all. It is simply the shape of a life, the return of seasons, the quiet accumulation of birthdays. But push outward, past Neptune, past the scattered ice of the Kuiper Belt, into the region where this hypothetical world may drift, and the very meaning of a year begins to stretch, to lose its familiar shape entirely. If this planet exists at the distances some models propose, its orbit around the Sun would not be measured in centuries, but in millennia, 10,000 years, perhaps 20,000, perhaps more, a single, unbroken lap around a star so distant that from its surface, if it has one, the Sun itself would no longer appear as a warm, generous disk in the sky, but as something closer to an unusually bright star, a pinprick of light among countless others, still recognizable, still the source of what little warmth and dim illumination this world receives, but utterly transformed by distance into something almost indistinguishable from the vast field of stars surrounding it. Try, for a moment, to hold that scale of time in the mind. 10,000 years ago, human beings had only just begun to experiment with agriculture, only just begun to settle into the earliest permanent villages, still many thousands of years away from writing, from mathematics, from the invention of the wheel. 20,000 years ago, entire ice sheets covered regions of the Earth that are now green and temperate, and the ancestors of every person alive today were living as hunters and gatherers, moving across landscapes utterly unrecognizable to us now. And somewhere during that same span, on this account, a single planet larger perhaps than our own, has been slowly, patiently completing a single orbit, has not yet finished it, and will not finish it for thousands of years still to come. This is the strange, vertiginous scale on which such a world would live its existence, indifferent entirely to the rise and fall of human civilizations occurring closer to the Sun, indifferent to the wars fought, the languages invented and forgotten, the empires built from stone and eventually reduced back to dust, indifferent even to the invention of the very telescopes now searching, however incompletely, for some trace of its existence. If it is there, it has been there for the entire span of recorded human history, and for a great deal of unrecorded history besides, orbiting slowly, faithfully, through a darkness so complete and so cold that the concept of a day, a month, even a human lifetime, becomes almost meaningless as a unit of measurement. And perhaps this is part of what makes the search feel less like ordinary science and more like something bordering on the sacred, an attempt to locate, within the overwhelming vastness of space, a single object whose entire relationship with time operates on a scale that dwarfs not just an individual human life, but the entire accumulated memory of our species. We are not simply looking for a planet. We are attempting to perceive, in a single human lifetime, the faintest possible fragment of a single, impossibly slow orbit, a sliver of motion so small against the scale of the whole that it would be like trying to notice the movement of an hour hand on a clock by glancing at it for less than a single second, and somehow, from that briefest of glances, inferring the entire unhurried shape of the hour it belongs to. This is why, even now, even with our satellites and our observatories and our increasingly sophisticated instruments, the search continues not in bursts of sudden revelation, but in this same slow, careful accumulation of evidence, each new observation another quiet, patient attempt to catch a glimpse of something that has been moving, in near total darkness, for longer than human memory itself, and will continue moving, whether or not we ever manage to see it clearly for 1,000 more years or 10,000, indifferent entirely to whether we exist at all to keep watching. Consider, for a moment, what it would mean if such a world truly does move out there, somewhere beyond the last faint glimmer of Pluto's own borrowed light. A 9th planet, or a 10th, depending on how the old arguments settle, orbiting so far out that sunlight itself becomes a rumor, a memory of warmth thinned by distance until it can no longer be called warmth at all, only the ghost of a promise the sun once made to everything in its gravitational care. Out there, at 400, 500, perhaps 600 astronomical units from the star that gave it birth, this hypothetical world would receive light so faint that its noon would look, to human eyes, like the deepest hour of an overcast night. And still, patient as stone, it would orbit. Still, it would obey the same laws that hold the smallest pebble to the surface of the earth, the same quiet mathematics that keeps the moon circling us instead of drifting away into the dark. This is one of the strange and steadying truths of gravity. It does not weaken to nothing, not ever, not even across the almost incomprehensible gulf that separates the inner solar system from whatever waits at its outer edge. It only grows fainter, and fainter, and fainter still, following an inverse square law so elegant it fits on a single line, and yet so absolute that it governs galaxies as easily as it governs falling apples. Distance dilutes gravity's strength, but never truly ends it. Which means that even now, even out past the Kuiper Belt's scattered rubble, even past the strange, tilted orbits of the sednoids that first hinted something massive might be shepherding them, the sun's gentle, invisible hand may still be resting on a world we have never seen, still gently, imperceptibly guiding it home. And that is what makes Planet 9, if it exists, so quietly unsettling to consider. Not that it might be large, though the current models suggest something between 5 and 10 times the mass of Earth, large enough to be called a proper planet by any reasonable definition, large enough to have its own internal heat, its own slow geological size, perhaps even its own thin atmosphere clinging to it like a memory of a warmer birth closer to the sun. Not that it might be strange, though it likely is, an ice giant exiled to the outer dark, its surface a landscape utterly unlike anything human eyes have ever witnessed directly. What unsettles is simpler than that, and stranger. It is the fact that something this large, this massive, this gravitationally significant, could be orbiting our own star, sharing our own solar system, bound by the same fundamental forces that hold us to the earth beneath our feet, and yet remain completely, totally unseen. Astronomers first began to suspect its presence not by seeing it, but by watching the way other, smaller worlds refused to behave the way they should. A cluster of distant trans-Neptunian objects, the frozen debris left over from the solar system's chaotic infancy, appear to have their orbits clustered together in a way that pure chance could not easily explain, their elongated paths all tilted in roughly the same strange direction, all pointing, in their long, slow arcs, toward the same quiet patch of sky. It was as though some invisible hand, some unseen source of gravity, had reached out over millions of years and gently combed these distant objects into alignment, the way a magnet beneath a table can arrange iron filings into an invisible pattern without ever being seen itself. This is the quiet, indirect signature of a hidden mass, gravity's fingerprint left behind on smaller, more visible worlds, evidence written not in light, but in absence, in the subtle choreography of things we can see responding to the pull of something we cannot. It is a peculiar kind of detective work, this hunting for planets by their gravitational shadows rather than their light. It asks astronomers to trust the mathematics even when the sky itself offers no direct confirmation, to build elaborate models of orbital mechanics and probability, to run the numbers again and again, checking whether pure random chance could produce such a strange clustering of distant, icy worlds, and finding, again and again, that chance alone seems an unsatisfying explanation. It is not proof, not yet, not in the way a photograph would be proof, a single frozen image with a small, cold dot sitting exactly where the calculations predicted it should be. But it is something quieter, and in its own way, more haunting, a mathematical certainty pressing up against an observational silence, a shape drawn entirely in negative space, sketched by the way everything nearby seems to lean, ever so slightly, away from where it should be and towards something we have never once managed to catch sight of directly. This is the peculiar burden carried by every serious search for Planet 9. The evidence accumulates steadily, patiently, convincingly, and still the world itself refuses to step into the light. It is there in the mathematics, and it is there in the way 6, then 10, then more of these distant icy bodies all seem to nod toward the same quiet region of sky, their long elliptical journeys around the sun all clustering with a consistency that grows harder and harder to dismiss as coincidence. And yet the world itself remains hidden, wrapped in a darkness so complete, so absolute, that even our most powerful telescopes, pointed patiently at exactly the right coordinates, might still miss it, simply because reflected sunlight this far from its source becomes so faint, so vanishingly dim, that it blurs into the ordinary static of deep space, indistinguishable, at first glance, from the ancient light of galaxies 1,000 times more distant. Think, for a moment, about what it actually means for something to be difficult to see. We tend to imagine visibility as a simple binary, a thing either bright enough to notice or lost entirely in darkness. But between those two states lies an enormous, patient middle ground, a twilight of near invisibility where an object is technically detectable, technically present in the data, and yet so faint, so easily mistaken for noise or artifact or distant background light, that recognizing it requires not just powerful instruments but an almost impossible kind of certainty about where, exactly, to look. This is the quiet tragedy of searching for Planet 9. The regions of sky where it might be hiding are vast, sprawling arcs of darkness stretching across enormous portions of the celestial sphere, and within those regions, the world itself, if it exists, might be moving so slowly, so imperceptibly, that even repeated observations of the same patch of sky, taken months or years apart, might fail to reveal the tiny, telltale shift in position that would separate a planet from a fixed and distant star. It is worth pausing here to consider just how slow that movement would be. An object at 400 or 500 astronomical units from the Sun would take somewhere in the range of 7,000 to 20,000 years to complete a single orbit, depending on the specific distance and eccentricity of its path. 20,000 years. Long enough that when such a world last stood exactly where it currently stands, no human hand had yet learned to shape a written word. Long enough that entire civilizations have risen from nothing, built their monuments, buried their dead, and dissolved back into the geological record, all while this single world continued its unhurried, indifferent circuit through the dark. Against a timescale like that, a human observation taken today and another taken a decade from now would show barely any movement at all, a fraction of a single degree, a shift so small it could easily be lost in the ordinary noise and error of even our best instruments. And so the search continues in the only way it reasonably can, not through some single dramatic act of discovery, but through years of careful, systematic surveying, of photographing the same regions of sky again and again, of comparing thousands upon thousands of faint points of light against one another, searching not for brightness, but for motion, for the subtle telltale drift that would separate a planet from the eternal, unmoving backdrop of distant stars. Astronomers using instruments like the dark energy camera and, more recently, the extraordinary wide-field capabilities of the Vera Rubin Observatory have begun conducting exactly this kind of survey, sweeping vast swaths of the southern sky in extraordinary detail, cataloging every faint object they can detect, and waiting, with a patience that borders on the monastic, for the data itself to reveal what human eyes alone could never hope to see in real time. There is something profoundly humbling in this method, something that speaks to the peculiar relationship between human ambition and cosmic scale. We are, after all, a species that evolved to notice fast movement, a rustle in tall grass, the sudden flash of a predator's approach, the quick flick of prey darting into shadow. Our senses were shaped by millions of years of needing to react quickly to danger and opportunity alike, tuned to a world where motion meant something immediate and often urgent. And yet here we are, turning that same evolved attentiveness toward the opposite extreme, training ourselves and our instruments to notice motion so slow, so vast, so utterly indifferent to any human timescale, that it can only be perceived through mathematics, through the careful, unglamorous accumulation of data points gathered patiently across years. We are, in this search, doing something our ancestors never could have imagined, straining not against darkness alone, but against time itself, against the sheer, dizzying slowness of a world that may be moving through space exactly as it always has, waiting, without any awareness of waiting at all, for the moment when a fragile species on a small, warm, inner world finally learns to look in exactly the right direction, at exactly the right moment, with instruments finally sensitive enough to catch the whisper of its passing. But suppose, for a moment, that we do find it. Suppose that somewhere in the coming years, a faint point of light in the Rubin Observatory's endless catalogue of images shifts, ever so slightly, against the fixed stars behind it, and an astronomer, tired, careful, half disbelieving, checks it once, then twice, then a dozen times more, and finds that the shift is real, that the mathematics finally has its confirmation, that the ninth planet is no longer a shape drawn in gravitational absence, but a genuine point of reflected sunlight, sitting exactly where the models always said it should. What then? What does it actually mean for us, for our fragile and temporary understanding of the place we occupy, to suddenly have a new planet added to the family of worlds that orbit our star? In one sense, very little would change. The sun would rise tomorrow exactly as it always has. The Earth would continue its own quiet, indifferent orbit, unconcerned with what we had or had not yet discovered at the edges of its gravitational domain. And yet, in another sense, something profound would shift, quietly, permanently, in the way we understand our own cosmic neighborhood. For centuries, we believed we knew the shape of our solar system, believed we had counted its major worlds, mapped its edges, understood its architecture well enough to draw it, simplified but essentially correct, in the front pages of every childhood textbook. And each time that understanding has been revised, each time a new world has emerged from the dark, whether Neptune, calculated into existence before it was ever seen, or the icy multitude of the Kuiper Belt, or the faint, tilted orbits of the Sednoids, we have been forced to confront the same quiet, humbling truth. We did not know as much as we believed we knew. Our map was incomplete. Our sense of the solar system's true boundaries was, and perhaps always will be, provisional, sketched in pencil rather than ink, ready to be redrawn the moment new evidence arrives. There is a particular kind of vertigo in this, a specific, quiet dizziness that comes from realizing that the place you call home, the solar system you were taught to imagine as fixed and complete and fully understood, might still hold entire worlds unaccounted for, planets larger than Earth, orbiting our own star, bound to us by the same gravity that holds the oceans to their basins, and yet entirely unknown to us until just now. It suggests, gently but unmistakably, that completeness is not a state we ever truly reach, not in astronomy, and perhaps not in any domain of human knowledge. We build our models, we chart what we can see, we grow confident in the shape of things, and then, patiently, the universe reveals another gap in our understanding, another shadow we had mistaken for empty space. And Planet 9, if it is finally found, would be only the most immediate example of this larger, more unsettling pattern. Because even its discovery, however remarkable, however historic, would not mean the outer solar system had finally given up all its secrets. It would mean, instead, that we had found one more piece of a puzzle whose total size we still cannot fully estimate. Beyond wherever Planet 9 might orbit, the darkness does not simply end. It continues, thinning gradually, imperceptibly, into the vast, cold expanse of the Oort Cloud, a shell of icy bodies so distant, so diffuse, that it may extend nearly a full light-year from the Sun, nearly a quarter of the way to the nearest star. Within that immense, spherical wilderness, untold trillions of comets drift in near-total darkness, some on such long, slow orbits that a single circuit around the Sun might take millions of years to complete. Somewhere within that same distant shell, some astronomers suspect, other unseen worlds might also wait, smaller perhaps, or larger, their gravitational signatures too faint, too diffuse, too deeply buried in the noise of distance to have yet revealed themselves to us. The outer solar system, in other words, is not a boundary so much as a threshold, a gradual fading from the world we know into a realm we have barely begun to map, a transition so slow and so vast that the very concept of an edge starts to lose its meaning. We speak sometimes of the solar system's outer limit as though it were a wall, a clean line separating what belongs to our star from what does not. But the truth, as it usually does, resists such simple boundaries. There is no wall. There is only an ever-thinning gravitational influence, stretching outward through Kuiper Belt debris, through the possible presence of Planet 9, through the icy multitudes of the Oort Cloud, fading so gradually into the vast emptiness between stars that no one can say with any real confidence exactly where the Sun's dominion finally ends, and where the deeper, colder gravity of the galaxy itself quietly begins. This is perhaps the strangest truth of all, the one that takes the longest to settle into the mind. Our solar system does not simply exist in isolation, a self-contained arrangement of sun and planets floating in some absolute, empty void. It exists nested within something vastly larger, a spiral galaxy some 100,000 light-years across, itself only one of perhaps 2 trillion such galaxies scattered throughout the observable universe. And even the outermost reaches of our own solar system, the Oort Cloud's furthest, faintest wisps of icy debris, still fall well within the gravitational influence of the Milky Way's own galactic tide, a slow, patient pull exerted not by any single star, but by the combined mass of hundreds of billions of stars, and by something even stranger still, the vast, invisible scaffolding of dark matter that seems to hold entire galaxies together in ways ordinary matter alone could never explain. Even here, even at what feels like the outermost edge of everything we might reasonably call home, we are still held, still gently tugged, still quietly governed by forces operating on a scale so much larger than our own that the mind struggles to hold the comparison for more than a few seconds at a time. Consider what it means for a single comet, drifting at the farthest reaches of the Oort Cloud, to occasionally feel not the Sun's gravity most strongly, but the passing gravitational influence of a nearby star, or the distant, diffuse pull of the galaxy's own rotational structure. At such extremes, the boundary between what belongs to our solar system and what belongs to the galaxy at large becomes almost philosophical rather than physical, a question not of clean division but of gradual, overlapping influence, one gravity fading just as another begins to make itself known. Some of the long-period comets we occasionally see streaking through our night sky, brilliant and rare and unforgettable, may have spent most of their existence teetering at exactly this boundary, nudged loose from their ancient, stable orbits by the passing gravity of a star we will never see, sent tumbling inward toward the Sun after untold millions of years of near-total stillness. only to blaze briefly and beautifully through our skies before continuing on some new, permanently altered path. Back into the dark. There is something almost unbearably poignant in this image. A piece of ice and rock, formed in the earliest, chaotic days of the solar system's birth, spending nearly the entirety of its existence in silence and cold and total isolation, only to be disturbed, perhaps only once, by a gravitational nudge so faint it would be difficult to even calculate, and in that single disturbance, sent hurtling toward warmth and light and, however briefly, toward visibility, toward the astonished eyes of some passing species on some small blue inner world, before vanishing once more into the same eternal darkness from which it came. It suggests that even the briefest, most fleeting moments of cosmic beauty, the comets we name and photograph and remember for years afterward, may represent the rarest possible exception to an overwhelming, almost total rule of stillness and invisibility, the vast majority of such objects living out their entire existence exactly as Planet 9 may be living out its own, unseen, unnamed, utterly unaware of and unaffected by whether anyone ever notices them at all. And this, perhaps, is the quiet, patient lesson that the search for Planet 9 ultimately offers us, if we are willing to sit with it long enough to let it settle. That the universe does not organize itself around the act of being observed. That vast, significant, gravitationally powerful things can exist, can shape the orbits of everything around them, can hold entire families of smaller worlds in careful mathematical alignment, all without ever needing to be seen, all without any awareness that seeing is even a concept that matters. We are the ones who need to see. We are the ones for whom visibility carries meaning, who feel a kind of incompleteness in not knowing, who cannot rest easily with a gravitational anomaly left unexplained. The universe itself carries no such need. It simply continues, indifferent and vast and utterly patient, allowing its planets to orbit in darkness for tens of thousands of years at a stretch, allowing its comets to drift for millions of years before ever catching a moment of sunlight, allowing entire structures of matter and gravity to exist in complete and permanent invisibility, not as some special exception, but as the ordinary, unremarkable rule. Perhaps that is the final, quiet gift of a search like this one, the search for a ninth planet we may or may not ever actually see. Not the discovery itself, whenever or if ever it finally comes, but the humility it teaches us along the way, the reminder that our need to observe, to name, to understand, to bring every corner of existence into the light of human awareness, is a profoundly human need, beautiful in its own way but not shared by the universe itself, which continues, and will always continue, whether or not it is ever witnessed at all. And so, as this long, slow drift through the outer dark comes to its quiet close, perhaps the truest thing left to say is not about Planet 9 at all, but about the particular kind of attention this search has asked of us. It has asked us to care deeply about something we cannot see, to build careers, decades, entire observational campaigns around the patient pursuit of a shadow, a mathematical inference, a gravitational fingerprint left behind on smaller, more visible worlds. It has asked astronomers to trust the elegance of an equation over the immediate satisfaction of a photograph, to hold, for years at a time, a kind of faith that is not religious but is nonetheless a faith, a confidence that the universe is consistent enough, lawful enough, patient enough to eventually yield its answer to those willing to keep looking in the right direction for long enough, with instruments sensitive enough to finally catch what has been hiding in plain sight all along. There is something in that patience worth carrying with us, long after the specific question of a ninth planet is finally settled, one way or another. Because the outer solar system, in the end, is not really about the outer solar system at all. It is about scale and about time, and about the strange, humbling realization that we are creatures built for immediacy, for the next hour, the next season, the next single human lifetime, suddenly finding ourselves capable of reasoning our way toward truths that unfold across tens of thousands of years, across distances so vast that light itself, the fastest thing in the universe, takes the better part of a day just to make the journey from the Sun to wherever Planet 9 might currently be, completing its long, unhurried circuit through the dark. We are small. We are brief. And yet we have built, out of curiosity and mathematics and an almost unreasonable persistence, a way of touching truths that dwarf us entirely, of holding, however briefly, an accurate picture of processes that will long outlast every single one of us, that were unfolding in exactly this way for millions of years before the first human eye ever opened, and will continue unfolding for millions of years after the last one finally closes. Perhaps that is the quiet, cosmic reassurance hidden inside a story that might otherwise feel unsettling. The sense of a vast, unseen world moving through permanent darkness at the edge of everything we know. Because darkness, out there, is not empty. It is not absence. It is simply distance, simply scale, simply the ordinary condition of most matter in the universe, most of the time, everywhere. To exist unseen is not a tragedy for a planet. It is simply what nearly everything in the cosmos is doing, in nearly every moment, across nearly the entirety of space. We are the strange exception, not the rule, small pockets of light and warmth and awareness, clustered here and there against an overwhelming, patient dark, briefly illuminated, briefly curious, briefly capable of turning our attention outward and asking, quietly, what else is out there, what else is moving, what else has been waiting, unnoticed, for longer than we can easily comprehend. And so, whether Planet 9 reveals itself next year, or in a decade, or not within any of our own lifetimes at all, its slow, hidden orbit will continue exactly as it always has, indifferent to our timelines, indifferent to our need for resolution, indifferent to whether this particular story ever receives its final, satisfying answer. It will keep moving through that thin, cold light at the farthest edge of the Sun's influence, tracing the same impossibly long ellipse it has traced for millions of years already, bound by the same quiet law of gravity that holds every one of us gently to the surface of this small, warm, extraordinary world we call home. And perhaps, on some ordinary night, long after this particular question has finally been answered, someone somewhere will step outside, look up into a sky scattered with far more stars than any single human lifetime could ever hope to name, and feel, if only for a moment, the same vast, humbling patience that has carried this entire search from its first uncertain observation to whatever quiet, eventual truth still waits, somewhere out there, in the dark. And on that thought, let the sky hold its silence a little longer, let the eyes rest, let the mind drift outward past every known boundary, past every named world, into the same slow, endless dark that has always been waiting, patiently, for nothing at all, except perhaps, eventually, to finally be seen.